Hi everybody, it's section 3.1, addition and subtraction of whole numbers. So we want to define what addition means. And this is a scary definition, I know, but I really want you to learn it, and I'll explain it and hopefully it'll look a little better. So here's the definition. Let A and B be whole numbers, and let A and B be disjoint sets. That means that A intersect B is the empty set, but really it just means there's no member in common, so that big A has little a members and set big B has little b members. Then we define the sum of little a plus little b as the number of elements in A union B. So let's see why it's not all strange. Well, really, it's because it's exactly what kids do, just in math language. So suppose I asked a little boy, Justin, to add 2 and 3. So that'd be a plus b would be 2 plus 3. My little a is 2, and my little b is 3. So what's he going to do? He's going to take two objects like cars. Those will be his set A, would be 2 cars. And he's going to pick 3 things, 3 trucks maybe. That's set B. And he is going to throw them together. That's a union. And then he's going to count them. And he counts 1, 2, 3, 4, 5, and the answer is 5. So it's just like the definition, really, if you think about it. Now, we have to be careful. Justin can't pick 2 cars and then 3 more cars, but the 3 cars, some of them are part of the 2 old cars. That can happen with a kid. Okay, I'll do 2 things and now I'll do 3 things, but I forgot that some of those new 3 are really part of my old 2, and then you get the wrong answer. So that disjoint part of the definition is really important. So a few terms. If A plus B is C, A and B are called the addends, and C is the sum. I think you should know these words. We should use sum certainly all the time. And there's some properties of addition that we should learn, and these kind of generalize to other things too. So the first one, if I take a set, and here we're just doing whole numbers today, the commutative property says that order doesn't matter when we add. A plus B is B plus A, 2 plus 3 is 3 plus 2. The associative property, think about your associates or who you group with, and the associative property says it doesn't matter where you put parentheses if you're only adding whole numbers. So A plus, group together B plus C, is going to give you the same answer as grouping together A and B first and then C. Notice here on the slide that the ABC order didn't change at all. I didn't use the commutative property by switching the orders of A, B, and C. I only switched where the parentheses were. There's also what we call an additive identity. An identity is somebody who lets the other guy always keep his identity. So if I add any number to 0, the answer is going to be that any number. Right? 3 plus 0 gets to stay 3. 0 plus 5 gets to stay 5. So 0 is sort of an identity preserver when we add. And finally, the whole numbers are said to be closed under addition. So notice that if I add 2 whole numbers, the answer has to be a whole number every single time. So let's look at some models you're going to use if you're going to teach. The addition models are a little boring, easy. The first one is the set model. So I want to add 2 and 3. I get 2 things. I get 3 things. I throw them together. I count them. That's exactly the definition of addition, right? That's one model. And the other is the number line model. And I apologize not for drawing these. There are beautiful pictures in your book if you look in section 3.1. If I want to add 2 plus 3, I get a number line. I start at 2. I hop to the right 1, 2, 3, and I am at the location on the number line 5, and that's my sum. All right, some methods for teaching addition. One really interesting thing if you watch small children, if you ask them to find 5 plus 3, they won't think of the fact that 5 is their whole left hand and then just add 6, 7, 8. So to find 5 plus 3 at the beginning, they will say 1, 2, 3, 4, 5, 6, 7, 8. But somewhere around first or second grade, they may get into counting on. So if I wanted to find 5 plus 3, they might say, okay, 5, and now I'll add 3, 6, 7, 8. So something you're not born with and you have to develop. For students who have trouble remembering facts, it can help them to learn doubles. So you learn 5 plus 5 or 6 plus 6, and then when you have a fact that's close to a double, you just adjust. So 5 plus 6 is 5 plus 1. Now I have a double 5, that's 10, and the 6 gave me 1 more than that, so my answer is 11. You can also adjust when you have a number really close to 10, because adding 10 is easy. So if I wanted to find 9 plus 7, I'd find 10 plus 7 and take 1 off because I did one number too big, 10 instead of 9. You could do something similar with 11 or 8. And another one that's kind of fun and more physical, take an egg carton that usually has 12 holes. You are going to make 10 cups. And then if I want to add 7 and 9, I'd fill 7 of the 10 cups. I now have 9 more. I'm going to fill 3 more just to get to 10. And now I notice I have 6 left that I haven't put in any cups, so the answer is 10 plus 6. And adding 10 is easy.